Okay. Click share screen. Okay, so I'm not here, but we have a lot to go over. You guys got this assigned last Thursday, this assigned last Friday, and then yesterday you got this assigned. We got to go over a ton of stuff so you guys are ready for the next step, even if I'm not here. So if you guys are planning on taking advanced geometry, this is kind of what it will look like, where you just gotta work independently and get your stuff done and email your teacher your questions. So really quick, let's start with this because we went over just this part yesterday before the quiz. So let's just talk domain and range. First of all, these are all quadratics. So let's just talk domain first. If I let this go infinitely to the right and to the left, the domain of a quadratic is always going to be all real numbers. So that's easy. And then remember the range, that's the y values, the possible y values. So first of all, it depends on if it's smiling or frowning. And it depends on where the vertex is. So we're going to come back to that in a second. Let's go to this side and we'll look at the vertex because that's the maximum or minimum point of each of these. So we're going to look at the vertex, we'll look at factored, we'll look at expanded, then we'll just revisit equations for lines of symmetry, the y-intercepts, and the x-intercepts. So if you remember very briefly, we said the vertex form of a quadratic looks like this. See what you think. Oh, I should put plus or minus h. That could be plus or minus k too. So if you think of it, the vertex we kind of noticed when we were looking at things that were graphed on Desmos. I'm just gonna pull that up so we can kind of compare, share screen Desmos. Okay. If I wanted to graph this equation, y equals x minus 6 squared. Oops, that's not 6. There we go. Look at where the vertex at. The vertex is at 6 and 0. So I'm going to write that down really quick. And then I'm just going to go ahead and graph the other one. Y equals negative 3 times x minus 5. Oops, keep doing that. Squared minus 9. So let's look at where the vertex is. What did I do? Oh, there it is right there. So the vertex is right there, 5 and negative 9. And we're going to just notice some patterns and see what part of the equation reveals it. And already, if you're looking at the equation, you've already spotted it. So we did y equals negative x minus 3 to the power of 2 minus 2. We'll probably just do this last one and you'll probably figure it out. So let's look at where the vertex is, the maximum or minimum point. 3, negative 2. I'm going to just make one up. Y equals x squared plus 4. So really quick, look at where the vertex is on this one. I'm just going to add it to the bottom of the sheet. Okay. So let's go back to this. All right. Here's the equation. There's the vertex. See if you notice anything. Here's the equation and the vertex. Equation, vertex. Even this one, equation, vertex. So I'm assuming something is jumping out at everybody. We've already talked about this, so it should. It seems that whatever you add or subtract to the end is the y value of the vertex. So you might be thinking, why is this one 0? Well, because what if there's nothing added or subtracted to the end? Well, there's always a secret 0. So even the one that I just added works. There's an add 4 added to the end, so that's why that's positive 4. Now let's take a look at the other part. The x value of the vertex is 6. This one is positive 5. That one's positive 3. That one is 0. So where do you think the x value of the vertex comes from when our equation's in this vertex form? and go back to vertex form, where you have some quantity added or subtracted to the x, and that would be in parentheses, right? Because that would be a translation horizontally. You've got your plus or minus some value that translates it vertically, up or down. Then you've got this multiplier out front that either stretches or compresses it vertically. And remember, a vertical stretch is a horizontal compression. And if this was a positive or negative, that would reflect it over the x or y axis. So we've seen this form. It's how we do transformations. So we call vertex form, but it's also kind of like the transformation form. So you're probably noticing that whatever this seems to be the opposite, right? If this is at x minus 6, if this is an x minus 5, it seems to be the opposite. But be careful. It's better to just think about this as what does x have to equal to make this equal 0? And the only reason I say that is because what if I flipped them around and I did 5 minus x? Right? So you're going to have to like think about it a little bit more here, because like what is the x value? You might say, oh, well, it's going to be negative 5. Negative 5, but no, because 5 minus positive 5 would be equal to 0. So it's not as simple as just saying opposites. You got to think your way through it. And we always make it equal to 0 because that is happening on the x-axis where all the y values equal 0. So that checks out here, which means now I can figure out the vertex here. I know that the x value is going to be negative 3, and what's being added on the end? Nothing. I know the x value here is going to be a negative 2, and what's added or subtracted in the end? Negative 1. I know the x value here is going to be a negative 3, and we've got this tacked onto the end. And if you look here, what's being added or subtracted to the x if there's nothing? Technically, could I write this like this? Sure. That means it's not translated left or right at all, so the x value is 0, and it's translated up 4, so that's 4. Okay? Now we got factored and expanded form of the equation. Expanded, remember, takes a little work. You got to figure out what x minus 6 squared is. You got to literally expand it. You got to put in the time, so I'm not going to put in the time on all those. I'm just going to put the answers up. But I want you to notice it took some time for some of these. So this one, you do the rectangle method or FOIL or whatever we want to call it, the arrows, the distributive property. So I want to take a look at the second one, though, because you still have to follow PEMDAS when you're simplifying. So if you've got negative 3, and then you've got this x minus 5 squared, which means don't distribute the square. It means there's 2 of them. PEMDAS says that if I can't do what's in parentheses, I should do the exponent. So that means you got to do this multiply first. So if I distribute that out, I get x squared minus 10x plus 25. And then I'm going to multiply that by negative 3. And then I'm going to take away 9. So my final answer is negative 3x squared plus 30x minus 84. So check your answer on that one. I'm guessing maybe a few kids missed it. Once you've got that far, then we're going to check to see if you can factor it. So now we got to revisit our factoring rules. Is there a greatest common factor? So let's check. I think all of these are divisible by negative 3. So if I switch colors here, if I divide out a negative 3, I'm left with negative 3 times x squared minus 10x plus 28. So now let's try to factor this. Not perfect squares, so leading coefficient is 1. So we're going to say, is there anything that multiplies to 28 and adds negative 10? You could spend all day, but this one right here, you're not going to figure it out. So I said if it wasn't possible, we could go and put that. Now that connects to the x-intercepts, right? because if it's in factored form, finding the x-intercepts is easy. Like you're trying to basically solve those for when y equals 0. And since these two factors are exactly the same, our only x-intercept is at 6, 0. Now for this one, I'm just going to put not possible for now. We could check to see if it actually even has an x-intercept, because I know it's frowning, and I know that its vertex is at 5, negative 9. So maybe like right here. Does it even have x-intercepts? There's none. NA, no, there's not possible. There are no x-intercepts. There are none. So knowing what that graph looks like, because you understand this vertex form, is kind of clutch. Now, for the equation for the line of symmetry, that's nice, because if you know the vertex, it goes through the line of symmetry. It goes through the x value of the vertex. So that's done. And if you can expand it and get it an expanded form, we also know the y-intercept. This one is at 0, 36. This one is at 0, negative 84, and so on. And so once you understand all these connections, this table becomes way easier. Okay, so I'm going to go ahead and put the whole answer key up. And this is probably where we should pause the video so you can check all of your answers. I put a not possible, I put a not possible. Okay, let me just do a little highlighting. Oh my God, there you are. Okay, just be careful. Watch PEMDAS when you're expanding these. Follow PEMDAS. Fractions, we can do this. That's doable. Just, again, follow the order of operations when you want to simplify something. We're not isolating a variable, so follow PEMDAS. Check your x-intercepts, see if they match. If I have a fraction but you have a decimal, then turn my fraction into a decimal and see if it matches. These ones that were blank were because they weren't factorable, so I couldn't go further. Shoot, they might not even have them. So don't worry too much about that. Okay, now I'm going to turn this over. Oops, get this on there. Oh yeah, sorry, we're backtracking here. So we know that all of the domains are all real numbers, but you kind of need that vertex then to find the range. So when you look, the vertex of this one is at 3 and negative 2, and it's frowning. So picture it. It's at 3, negative 2, and it's frowning. So all of those y values are going to be under negative 2. So let's check this next one. This one is at negative 3 and 0, and it's smiling. So it's going to be at negative 3, 0, and smiling. So all the y values are going to be greater than 0. This one right here is at negative 2, negative 1, and it's smiling. Oops. Negative 2, so it's going to be right here. So it's going to be all the y values greater than negative 1. And then this one is at 3, negative 4, and it's frowning. So it's at 3, negative 4, and frowning. So it's everything less than negative 4. Okay, I'll pop those in and just put this on the board, but for now, that's where we're going to stop.